The Pythagorean Theorem. Alright, so let's start with this. Let's start with these three squares for a second. Okay, if I want to ask you the area of this first square here, how would I find the area of this first square? First off, it has 3 units, so the area would be what? Length times width, or another way to think about it, if you have a square, is what? Area equals side squared or s squared. Okay, so this would be 3 squared, which would be 9 units squared. This here is 1, 2, 3, 4, 5 units long, so this would be, what would my area be here? 25 units squared. And then this one's 4 units long, so this would be 16 units squared. Alright, so let's see how this goes. So the Pythagorean Theorem, okay, what the gist of it is, if you have a triangle, okay, and you have a side, one of the side lengths here is 3. So you have 1, 2, 3, it's 3 units long, and you draw a square from here to here for this side here. Looking at your other square, on your other side here, you could take and draw another square down here. And then you're using this length here, which is opposite your 90-degree angle. So these two legs make a 90-degree angle, and opposite that 90-degree angle, or this right angle, is called the hypotenuse. Okay, so this is my hypotenuse here, and if I create a square here, I'll have these 3 squares here. And now what the Pythagorean Theorem says, if I draw this square here, then this sum of these 2 squares, so the sum of this square and this square, so the sum of these 2 squares, 9 units squared and 16 units squared, is going to equal the sum of this hypotenuse squared. So this will equal 25 units squared. Alright, so that's the basic gist of your Pythagorean Theorem. So this side here, so a squared plus b squared is equal to c squared. So let's get that one down. So we got Pythagorean Theorem reads a squared plus b squared equals c squared. A and b are interchangeable, but c is always going to be your hypotenuse. Okay, they're all variables in a sense, so you could technically put any variables you want, but just keep in mind it's the sum of the 2 legs that equal the hypotenuse. Okay, let's look at some examples. So here's our first example. A squared plus b squared equals c squared. I'm solving for c. So if I want to plug in here, I have my legs are a and b. And these are interchangeable. Okay, this could be a, this could be b, it doesn't matter. Right? But this side here, opposite my right, has to be my c. So now I have 3 squared, plugging in for a, plus 4 squared is equal to c squared solving. 3 squared is 9. 9 plus 4 squared is 16, which equals c squared. 9 plus 16 is 25, equals c squared. And now I want to solve for c, not c squared. How do I get rid of a square?
Square root.
Take the square root. What I do to one side, do to the other side. So c equals the square root of 25. Now technically the square root of 25 is equal to positive or negative 5. I'm not going to count the negatives here. Why not? Why am I going to just look at the positive sides here? What am I looking for here? What am I looking for? Why am I not going to count the negatives? So I'm looking for A. A represents the what of this triangle? A represents the what of this triangle? The length, or base, the length of the triangle. So can you have a negative length? So that's why I'm only going to look at the positive solution for C. Next example. A squared plus b squared equals c squared. Okay, I'm going to use the same number so we know what the answer is, but in this case, I just want to show you how, if we're looking for a. So here we have a squared plus, we know what b is, 4 squared equals, and we know what c is, 5 squared. So if we substitute in, we're going to get a squared plus 16 equals 25. I'm solving for a squared, so it becomes a 2-step equation. Subtract 16 from both sides. So you get a squared equals 25 minus 16, which equals 9. I don't want a squared, I just want a. Get rid of the square by taking square root of both sides. So here a equals 3. Alright, so depending on what you have, if you have the leg, make sure you solve for the leg. If you have the hypotenuse, make sure you solve for the hypotenuse. Okay, so make sure you know what you're looking for. Alright, now solving for b here, same thing as solving for a. So my a is 3 squared plus b squared equals 5 squared. Substituting in, now evaluating, 9 plus b squared equals 5 squared. Equals 25. Subtract 9 from both sides. You're going to get minus 9. B squared equals 16. Solve for b. Take the square root of both sides. B equals 4. So we know that the 3, 4, 5 is a right triangle. And that's one very, very common lengths for these right triangles. 3, 4, 5 right triangles. Now another way to use this Pythagorean theorem is using the converse of the Pythagorean theorem. Meaning, if I give you the 3 sides and I ask you, is this a right triangle? Okay, I'm giving you the 3 sides and I'm asking you, is this a right triangle? Well, to show this, then you're going to say, okay, well, if this fits the form of a squared plus b squared equals c squared, then this is a right triangle. So here, a is 5, b is 12, and c is 13. So if I plug this in, does 5 squared plus 12 squared equal 13 squared? If it does, then this is a right triangle. 5 squared, 25. 12 squared, 144. 13 squared,
169.
add these two together, 25 plus 144, what do I get?
169.
So does 169 equal 169?
Yep.
So in this case, yes, this is a right triangle. Now we're going to do the same for the rest of them. So our next example is 7, 24, and 25. So does 7 squared plus 24 squared equal 25 squared? If it does, then it's a right triangle. 7 squared is? 24 squared is? 576. And 25 squared is?
625.
If I add these two numbers, do I get 625?
Yes.
So 625 equals 625. Check. This is a right triangle. Perfect. Next one. Does 6 squared plus 8 squared equal 12 squared? 6 squared,
36.
8 squared,
64.
and 12 squared.
144.
36 plus 64, I get 100 equal to 144. Are these equal?
No.
Not equal. I'm going to put a little line here. So this is a no. This is not a right triangle. Okay, all three of those have to equal each other. Let's get rid of this one. And then my last one. Does 4 squared plus 5 squared equal the square root of 41 squared?
Oh, it's square.
Does 4 squared plus 5 squared equal the square root of 41 squared? So again, does a squared plus b squared equal c squared? The square root could throw you off possibly, right? You're thinking, okay, let me take the square root of this. But I still have to square. So 4 squared is? 5 squared is?
25.
And the square root of 41 squared, what happens to these?
Cancel out.
They simplify, so you're just left with
41.
41. What's 16 plus 25?
41.
Does 41 equal 41?
Yes.
Yes, so this is also a right triangle.
Oh yeah,
So Brian uses a 15-foot ladder to paint a windowsill that is 12 feet above ground. So here's his ladder, it's 15 feet. Here's a windowsill. How far from the base of the wall, so how far from the base of the wall should he put this ladder? So we're looking for this height, this distance here. Here's my right angle, so this is called my what? The ladder is the hypotenuse, or my C. 12 could be my A, and this could be my B. All right, again, the A and the B are, you could interchange them, it doesn't matter. So then I have A squared plus B squared equals C squared using my Pythagorean theorem. I know that A is 12, so 12 squared plus B squared, which is missing, equals 15 squared. 12 squared is
144.
plus B squared equals 15 squared, 225. Solving for B squared, subtract 144 from both sides. This goes away. I'm left with B squared equals 225 minus 144, 81. Am I done?
No.
Square root, square root. B equals 9. 9 what?
Unit squared.
Well, in this case, we know it's feet, so 9 feet. So he needs to keep his ladder 9 feet away from the base. So what is the length of the line segment? So we have two ways to find length. One is the distance formula, okay, which we'll get into in another lesson. And then we're going to use, for this case, to find this length, we're going to use the Pythagorean Theorem. So I have this slant here, I slant the line. What I'm going to do is create a right triangle out of this. So that line here now becomes my what? Is my hypotenuse, okay? So I have my A, I have my B, and now this is what I'm looking for my C. So what is the distance of my A? Now it's a vertical line, so very nice and easy. I could just do what? How do I? Yeah, count them. So 1, 2, 3, 4, 5, 6. So A is 6. What is my B? 1, 2, 3, 4. And now my C is my unknown. So then very nicely, we're going to say 6 squared plus 4 squared equals C squared using my Pythagorean theorem. 6 squared is
36.
plus
16.
equals C squared. 36 and 16.
52.
So 52 equals C squared. Is 52 a perfect square?
No.
Okay, so I still want to solve for C, so I'm going to take the square root of both sides. So here's two different answers you can give me. C equals the square root of 52, which approximately equals what? So if you approximate this, so it's approximately equal to 7.2. Unless I ask for the exact value. Now if I'm asking for the exact value, which I will do in many circumstances, we need to break this up into two factors. What are factors of 52? Now one of these factors you want to try to get into a perfect square, something I could take the square root of. So I could definitely multiply 52 by 4. So this becomes 4 times 13. These are two factors of 52. 4 times 13 is 52. I chose 4 because 4 is a perfect square. So this is the same thing as saying the square root of 4 times the square root of 13 if you want to look at them separately. What is the square root of 4?
2.
Can I take the square root of 13?
No.
So my answer will be 2 root 13 as an exact answer. This will be your estimate. This will be your exact. Okay, so depending on what the problem is looking for or asking for, make sure you give the exact or the estimate.
So